All right. So on excavation, OSHA sets the standards for how they believe the minimum standards for safety should be set. We do things a little bit higher standard, which is good, and we'll work our way through each of these. Now, OSHA doesn't have the working authority for each of these sections, but in the Code of Federal Regulations in Chapter 1926 is where the construction standards are. So for traffic cones, safety glasses, most of the PPE, the high visibility, they refer to other authorities, and we're going to talk about that. The goal is to kind of immerse you into the regulations. I'm not going to share the codes, those types of things. I'm going to try to make it as interesting as possible. But you guys, at the end of section 2, when we go through the tabulated data, John Schultz, who is our regional safety specialist, he's going to teach module 2. At the last slide, he's got a QR code for himself and myself. You can just take a picture of that and put our contact information in there. Use this as a resource. I've been in trenches. Yes, I've never been the operator for any of our excavations. So all of my knowledge is up here. Plus, I've been in the field for a lot of excavations. If you have a question that I can't answer, there's definitely a cabinet of advisors that we've built for excavation. People from Toledo, Ohio, Chicago, Illinois, like world-class excavators that teach on this subject inside the United States that have helped us make some decisions. So without delaying any further, we're just going to move along here. A competent person is somebody who identifies a trench hazard. The way that we structure things at Roto-Rooter is the competent person is the operator. What works out best is if it's the spotter who is the competent person, and even better, everybody's a competent person. And I think that's part of the vision that John has for your office. But a competent person needs to be able to identify trench hazards, and we'll work our way through each of those hazards. The competent person also is authorized to take very swift corrective measures to eliminate that hazard. So, for example, you see something wrong, you have the authority to stop that job, to pause that job, and make that correction before continuing that job. The competent person also is responsible for daily trench inspections with ServiceTitan. The ServiceTitan AI will dispatch the daily excavation inspection checklist to every single person on that job. Only one person needs to fill out the report. So, for example, typically whoever the operator is the competent person. So when you're looking at ServiceTitan and it says, are you the competent person, and you're a spotter or you're the underground specialist, the answer is no. You want to make sure that at least one person is filling out those reports. We'll get into that as the class goes on. So you have the authority to be able to pause a job, stop a job. You have the responsibility of doing the daily inspections. You have the responsibility of identifying the trench hazards. You need to be knowledgeable about soils, different protective systems, and the OSHA regulations. And today's class is designed to kind of immerse you in that. We basically use two main types of protective system. We'll use shielding or trench boxes. We'll use speed shore. That is in combination with fin form boards. As it relates to soil, this is a test question. We classify everything as C here at Roto-Rooter. So when it comes to your mid-dig report in Service Titan, you only have one option to classify soil, and that's C. We classify all soils as C because more than likely that soil has been previously disturbed. Even if it was 50 years ago and they put the original water line in or the original sewer when the development was put in. The second reason we classify all soils as C is because it requires the highest level of protection.
On this computer.
So my goal is to make you guys competent to be able to recognize these things, know how to mitigate them, and how to complete the paperwork. So a competent person, be able to recognize trench hazards, choose the right protective system for your excavation, classify the soil in Service Titan, to inspect the protective system. We don't typically put structural ramps into our excavations. It's something we can do, but we typically don't. Water removal, if we're working in a situation where water is accumulating in the trench, we need to be able to address that, pump that water out. OSHA considers 2 inches inside of a trench to be a drowning hazard, so it has to be mitigated. And then conducting the site inspections. So as your day begins and you have your meeting with your field supervisor, they hand you that excavation folder so you know where you're going, you know which fern cones to get, make sure you have all your tools, everything's loaded and ready to go, and you pull up to the customer's house. The first thing you need to do is put your high visibility vest on, and you're going to start setting up the roadway. This is where the cones come in place. So basically, there's always around 3,000 work zones in the traffic during heavy construction season. I'm in the Allentown, Pennsylvania office today, and there was quite a bit of Pennsylvania construction. About 12 billion vehicle miles are driven through work zones, to give you an idea, every year. That's a lot. And 40,000 people are injured every single year in a work zone. When you're setting up your truck and trailer with excavator, you're creating a work zone. Even if you're working in the yard, which typically is where we dig, you're parking in the street, that becomes a work zone. And so basically in the United States, there's a fatality every 8 hours. I was in the fire service before doing this particular job, and construction area accidents most oftentimes were fatal. I worked in a very busy part of Ohio, and we had the most fatal accidents in the state in our fire department, and it was seldom was it fun. Oops, sorry about that, guys. And so because of that experience, I try to help set up the work zones so that you guys are most protected. The regulations specifically give us some options here. We can use these barricades. We can use the drums. The most economical way to go is cones. And so subpart G in 1926 in the OSHA regs, it gives us the standards for cones. As an enterprise, we basically try to buy just one cone, 28-inch cones that have the double banded retroreflective striping on it. What this does, it allows us to use this particular cone in the daytime in the highway at a 25-mile-an-hour residential area, a 55-mile-an-hour industrial highway, throughway, whatever it's called in Indiana. And so these are the cones that we buy. I'm going to skip this video on retroreflective here. Reflective is the way of the past. What that did was that you shine the light typically from your headlights onto a stop sign, a barricade like this. On the reflective banding, that light comes back to you at multiple angles. The retroreflective banding that we're using now brings just about all of that light that your flashlight, your headlight shines at that object. Most of that comes back to you. So if you're looking at something that's retroreflective striped, it's going to seem really, really bright with your headlights. If it seems dim, typically the old fire hydrants still have a lot of the reflective banding. So if you shine your light on a fire hydrant, it seems dim. The new stop signs have the retroreflective striping on it. It'll seem brighter. That's the value of it. So only retroreflective double banded cones at 28 inches tall. Not only is there a standard for the type of cone that we use, but how many cones based on the miles per hour that we're working in. We're setting up our work zone. For example, the code specifically says you take the miles per hour, you divide it by the number 5, and then you add 1 cone. So if you're working in a 35-mile-an-hour residential area, you need at least 8 cones. If you're at 45, you can do the math. 55, you can do the math. Typically, you're going to need 8 cones. And of course, the regulations are very detailed. Which kind of cone, how tall, the double banding, how many, and how it gets set up. So initially, if you're working on the other side of a hill, you need to have a flag that says work zone ahead, construction area ahead, to try to give the people who are coming into your lane on the other side of the hill as much advance notice as possible. It's not going to help every single person, but it's going to help a lot. In addition to that advance warning area, you have the transition area to where you begin to block off a section of road. Even to park your car in a residential neighborhood, this is what you have to do. Then you have the buffer space, if you notice, in the middle there, and then your workspace. We typically don't always dig in the street. Very seldom do we do that. We do that, but seldom. Oftentimes we're in the customer's yard. However, once you go to your truck, that becomes the work area. And I'll show you some slides here that they don't make it easy. We try to, but the regulations make it really complicated, all kinds of extra things to have to remember. The manual on uniform traffic control devices for streets and highways is the regulatory source for setting up your work zone. What I try to encourage us to do is just outside of the transition area here, this is where we park our equipment. So if we're constantly running to our truck for tools, I want the trailer here in the back. Even better, we can park at this degree, this canting, a vehicle. The cones aren't going to stop a car. The drums, the barricades, they're not going to stop a car. And depending on the speed, our vehicles may not stop a car, but there's a really good chance that it will. And so like in the fire service or law enforcement, you park your vehicle at an angle towards the center of the road. And that allows somebody, if they're not paying attention, they hit that vehicle, it'll displace them to the center of the road away from where we're working. Then you have the termination area in zone 4. That's where the angle comes back to the street and allows the people to get back in their lane. If you're short on cones, the place that I want you to short yourself is in the termination area. So if those cones just keep going straight, you don't have enough cones to terminate, on a particular job, that's fine. I know that sometimes you guys can get double booked. You start a job one day and then you go to finish another one, and you may have some equipment there. I understand that. If it's something that you notice, though, that you are short on cones, please let me know. I will order them and get them shipped to your branch right away. Any questions on cones, Logan? Jared? All right, you're doing good. You're still staying awake. That's good. Okay, so high visibility clothing. This is a requirement. The OSHA standard, it tells us what specific areas we need to wear high visibility vests in, high visibility shirts, those types of things. And it says specifically in part 6E.02, working on a street, next to a road, or anytime in the right of way. We try to make it really easy. It's our policy that anytime you're out on an excavation, you're wearing a high visibility vest, a high visibility t-shirt, those types of things. So the regulations specifically say anytime in an urban 4-lane section of road, high visibility vest. When you're in the right of way in a development, you can see that it goes way past the tree lawn, the sidewalk, and halfway into the landowner's yard. So that different setting, different set of measurements, we make it a requirement procedurally in our policy that you wear high visibility anytime you're on an excavation. This is a day class 2. This means that the tag in the back of the vest or the shirt or even a sweatshirt, depending on the season and what you're wearing, it needs to have a rating of R. R for roadway. Class 2 is for daytime. You see the difference between class 2 and 3. Class 3 allows you to wear it at night because it's got the sleeve, the retroreflective banding on the sleeve. Something to pay attention to also on the details, the washing instructions. High visibility loses its high visibility properties after 25 wash cycles for this particular vest. And you may think to yourself, do they really expect me to keep track of how many times I wash my vest? If we get deposed, yes, it's going to be one of the questions. So you can tell, though, when somebody's high vis lost their properties. So class 2 for the daytime, class 3 for night. Even if your dig starts before it gets daylight, you need to wear the class 3. If you're working past daylight and it's well into dusk and night, then you need to wear the high visibility class 3. So trenching and fatalities, trenching fatalities and injuries are still way too high. I was at OSHA training last Wednesday, where the OSHA leadership for the state of Ohio did a variety of different classes. And so the main OSHA guy told us that for Ohio, there's 3 amputations every single week in workplace accidents in the state of Ohio. You'd think that would be absolutely ridiculous. And it is, but I don't know why it's that high. It's just that bad, I guess. But in excavation, there's 1,000 people that are injured in the United States for excavation and trenching, and about 30 people die still in the United States in a trench fatality. I know not far from you guys, no, I'm thinking of Peoria. In Peoria, Illinois, I want to say it was 3 weeks ago, we had a man from our competitor, Mr. Rooter. They were doing an excavation. They didn't use any protective system, and the man was buried up to just above his knees. It took them about 3 hours to uncover him, to get his legs unburied. So it does happen. I know somewhere not so far from Muncie was a fatality at the end of last year from a trench collapse. But the thing is, we don't want any of those uh, injuries or fatalities. We don't want them here. You guys are too important to us. We want you to go home. You're working to support yourselves or your families. You're contributing to the business growth and the development. You guys have an important role. And so we've established this whole training and everything to keep you guys safe every single time. We have a little bit higher standards because I have 4 kids. I put the standards in such a place that I want any of my 4 boys to go into any of your trenches that you dig, and I want it to be safe for you guys. Some of the common causes for injuries and fatalities: no protective system. People aren't using the speed shoring system. They're not using trench boxes, or if they are, the equipment is all beat up because of abuse. They're not inspecting it. Placing the spoil pile closer than 2 feet. You want to at least keep it a minimum of 2 feet. Farther away is even better in case the locate is wrong and you've got to move your trench over another 12 inches, 14 inches. You want to kind of a plan for that. Some of the current injuries are from people in the United States skipping the step of putting a ladder in place. So they're just hopping into the excavation and hurting their wrists or hurting their ankles. And we don't want that here either. So if you just follow this plan, call me, use me as a resource through any excavation. I don't keep banker's hours. I want to be a help to you guys. So how do we define an excavation? How do we define a trench? An excavation is anytime you put the shovel in the ground and you're removing a shovel full of dirt up to any other cut, man-made trench or depression in the earth. A trench is a narrow excavation, and a trench is deeper than it is wide, and it stops being a trench if at the bottom of your excavation it is 15 feet wide at the bottom. Hold on. Okay. All trench walls will eventually fail. Have you guys seen any trench walls fail yet while you were digging? Jared? Yeah, okay, you're still on mute here. So a cave-in here specifically it comes in a couple of different ways. I've seen both of these, the sliding and the toppling, in our excavations before we put anybody in there, before we've even had a chance to classify the soil. I think about 3-4 weeks ago, I was in the Ohio market and on an excavation on a Friday afternoon, and it was mostly sand just outside of a lake neighborhood. And we just had to do a build-a-box, a trench box, to keep all that from sliding in there. Any kind of sudden movement, once the soil separates from the rocks or tree roots, that's typically what contributes to sliding or a toppling. Gravity is always at work there. And then when we add the extra weight of the dirt we've removed, and we're putting it on the sides, not only is there nothing to keep it from collapsing outside of a protective system, but now we're adding more weight to walls that are already compromised. This is why we need to use a protective system. I'm going to share this video here on a survivor from a trench collapse.
So I was buried.
Can you hear that okay?
A little bit below my neck. I mean, complete. And it was by far not the most dangerous ditch I've ever been in. anything that's ever happened, I was always able to escape. You know, wall would come down, I'd be able to get away. I was never trapped. So I think that the more digs that I did without anything happening, the more my false sense of confidence grew. Gotten out of the backhoe, jumped in the hole, and was starting to uncover the front, you know, the front where the pipe was exiting the house. And I looked up, the front of the wall was starting to crack. And as I stood up, out of my peripheral vision, the whole sidewall just came in. And all I was able to do was turn, and every ounce of air left my body. It was scary, for sure. So I was buried up to a little bit below my neck. I mean, completely. Thank God for the guy that I was working with. He was, because I've had some helpers along the way. I would have been dead. There's not a doubt in my mind. They would have just frozen, not knowing what to do. And thankfully, he was smart enough to he didn't even hesitate. I mean, as that came in, he was coming into the hole, and it just, yeah. I mean, I was just watching him dig the dirt off it, and I was just waiting for to be able to breathe. If you don't want to die in a ditch, if you don't want to feel the feeling of losing every ounce of oxygen in your body, you get shown. That's the bottom line.
Like I said, 1,000 a year. It's just not worth it. The soil is dense and it's heavy. There's all kinds of different measurements for a cubic foot, a cubic yard of soil. We'll talk about a couple of those. The reality is that it takes 3 to 6 hours to uncover somebody. And that is a full burial up to the waist. It can take 3 hours because everything has to be done by hand. You can't use any mechanized tools. You want to be extremely careful with using hand tools, and typically majority of the work is uncovered with your bare hands. It's not good. The pressure that comes is it's alarming, and the speed that it happens. We classify soils at Roto-Rooter as C, but there are different soils outside of Roto-Rooter that you can classify stuff. So this competent person training is just good for the Steplewoy family of businesses. And so because of C, the classification of C, we are going to put a higher safety system around us just to keep our team at a higher level of protection. But there's certain things that you can do outside of Roto-Rooter. If your soil is an A or a B, you have some other options. We'll talk about some of those. But the competent person, they're the person who's responsible for determining the soil type. They're the only ones who are going to enter C as the soil type in Service Titan. There's other classifications. Stable rock typically requires dynamite to blast through initially. There's A, there's B, C gets broke down into C60, C80, but we're not too worried about any of that. I want to share this video here with you.
In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills 40 construction workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows one of the steps, classifying soil, that employers must follow so that trenching work can be done safely. This video is not intended to be a complete educational tool. Instead, it is meant as an introduction for people who want to know more. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll learn how having the right information about a construction site can help save lives. Each employee who enters a trench must be protected from cave-ins by a protective system, if the excavation is 5 feet or greater in depth, unless it is dug into stable rock. A support system is not required if the trench is less than 5 feet in depth. An examination of the ground by a competent person provides no indication of a potential cave-in. 1 cubic yard of soil can weigh as much as a car, 3,000 pounds, and comes in many varieties. Some trenches that are 5 feet or deeper must follow OSHA's rules. The appendices of the OSHA excavation standard show the various types of support systems that may be used, up to a maximum depth of 20 feet. Any excavation deeper than 20 feet must use a protective system approved by a professional engineer. For all excavations, a competent person must conduct a full investigation every day, or when any trench conditions change, to identify and remove any potential hazards. In this video, you'll see how a visual inspection of a construction site soil is performed. You will also see how to test the soil using 3 of the most common methods: the plasticity test, the thumb penetration test, and the pocket penetrometer test. For best results, OSHA recommends that the competent person use more than one of these methods to test the soil. Knowing the type of soil makes it possible to determine the right protective system to keep workers safe when they're working in an excavation. Soil can either be cohesive or granular. Cohesive soil contains fine particles and enough clay so that the soil will stick to itself. The more cohesive the soil, the more clay it has, and the less likely a cave-in will happen. Granular soils are made of coarse particles, such as sand or gravel. This type of soil will not stick to itself. The less cohesive the soil, the greater the measures needed to prevent a cave-in. OSHA uses a measurement called unconfined compressive strength to classify each type of soil. This is the amount of pressure that will cause the soil to collapse. This value is usually reported in units of tons per square foot. Soils can be classified as Type A, Type B, or Type C. Type A soil is the most stable soil in which to excavate. Type C is the least stable soil. It's important to remember that a trench can be cut through more than one type of soil. Let's look at each type of soil. Type A soil is cohesive and has a high unconfined compressive strength, 1.5 tons per square foot or greater. Examples of Type A soil include clay, silty clay, sandy clay, and clay loam. Soil cannot be classified as Type A if it is fissured, if it has been previously disturbed, if it has water seeping through it, or if it is subject to vibration from sources such as heavy traffic or pile drivers. Type B soil is cohesive and has often been cracked or disturbed, with pieces that don't stick together, as well as Type A soil. Type B soil has medium unconfined compressive strength, between 0.5 and 1.5 tons per square foot. Examples of Type B soil include angular gravel, silt loam, and soils that are fissured or near sources of vibration, but could otherwise be Type A. Type C soil is the least stable type of soil. Type C includes granular soils in which particles don't stick together, and cohesive soils with a low unconfined compressive strength, 0.5 tons per square foot or less. Examples of Type C soil include gravel and sand. Because it is not stable, soil with water seeping through it is also automatically classified as Type C soil, regardless of its other characteristics. Before testing the soil, it's useful to perform a visual test of the construction site. This will help determine if there are factors on site that will lower the strength of the soil. Here are some observations to make when performing a preliminary visual test of the soil around an excavation site. First, as the soil is being excavated, does it come out in clumps or is it granular? Clumps mean that the soil is cohesive. Are there sources of vibration near the excavation? Are there signs of previously disturbed soil, such as utility lines? Are there signs of water seeping through the soil? Is the soil fissured? Signs of fissuring include crack-like openings or chunks of soil that crumble off the side of a vertical excavation wall. If any of these conditions are met, the soil cannot be classified as type A. When performing a soil test, it's important to choose a good soil sample. Soil samples should be typical of the surrounding soil in the excavation, and additional samples should be taken as the excavation gets deeper. While the excavation wall is one place to take samples, OSHA recommends taking a large clump from the excavated pile, as long as the soil in the pile is fresh and hasn't been compacted. Test results can change as the soil dries up, so for the best results, samples should be taken and tested as soon as practical. Now let's look at the three main types of soil tests. The plasticity test, which is sometimes called the pencil test, is used to determine if the soil is cohesive. This test is performed by rolling a moist soil sample into a thread that's 1/8 of an inch thick and 2 inches long, resembling a short, slim pencil. If the sample can be held at one end without breaking, it is cohesive. Here's an example of what the results will look like if the soil is cohesive. Notice how the sample stays in one piece. Now look at what happens when the soil is not cohesive. The soil doesn't have the strength to hold itself together. Any soil that is not cohesive is automatically classified as type C, although some type C soils are cohesive. The thumb penetration test is used to quickly estimate the compressive strength of a cohesive soil sample. To perform the thumb penetration test, simply press the end of your thumb into a fresh clump of soil. If the soil sample is type A, your thumb will only make an indentation in the soil with great effort, as you can see demonstrated here. If the soil sample is type B, your thumb will sink into the soil up to the end of your thumbnail, just like this. If the soil sample is type C, your thumb will sink all the way into the soil clump, as you can see here. Your results for this test will probably be somewhere in between these results. For a more numeric measurement, the pocket penetrometer test can be used. A soil's compressive strength can be given a numeric value by using the pocket penetrometer test. There can be some variability in these results, so it's a good idea to run this test on a few soil samples from the same part of the excavation, just to make sure your results are consistent. A pocket penetrometer works much like a tire pressure gauge. A thin metal piston is pushed into a soil sample, and the penetrometer records the compressive strength of the soil. Be sure that the scale indicator is inserted into the penetrometer body until only the 0 mark is showing. To conduct the test, push the piston into the soil until it reaches the engraved line. Then simply take the reading from the scale indicator. It's important to recognize that a penetrometer may give false results if the soil contains rocks or pebbles, which won't compress. As you can see, type A soil will measure at least 1.5 tons per square foot. Be aware, however, that you can't classify a soil as type A if the excavation site didn't meet all the conditions of the visual test. If it is granular, near a source of vibration, or there are signs of previously disturbed soil, water seepage, or fissured soil. For type B soil, the reading will be between 0.5 and 1.5 tons per square foot. Type C soils are equal to or less than 0.5 tons per square foot. Let's review the main points from the video. OSHA classifies soils into three main groups: type A, type B, and type C. Type A is the most stable, and type C is the least stable soil. To determine the soil type on a construction site, there are several tests that a competent person can use. After performing a visual test, you can use the plasticity test to determine if the soil is cohesive or granular. For cohesive soil, the thumb penetration and pocket penetrometer tests help determine the unconfined compressive strength. Determining the type of soil on a site will help a competent person decide which methods of sloping, benching, or shoring are needed to prevent cave-ins and keep workers safe. For more information, visit the OSHA website at www.osha.gov, where you can read the OSHA excavation standard, or use OSHA's construction e-tool for trenching and excavation. You can also contact OSHA at 1-800-3.
So the benefit of that is we make it simple for you and classify everything as C. With clay, closer to the A type of soil, it can weigh 65 pounds per cubic foot. If you're digging an 8-foot excavation, by the time that 1 cubic foot, 65 pounds, gets to the bottom of the excavation, it's traveling 35 miles an hour. If that 65 pounds hits you in the knee at 35 miles an hour, that is going to hurt. If the clay has absorbed as much water as it can weigh 110 pounds. And that's a lot. So we watched that video, so I'm going to skip the lecture part of it. Again, it's a test question. We only classify soils as C on Service Titan because it's been previously disturbed and requires the highest level of protection. And we're going to close out this section with this video here. That's how fast a fatality happens there. You just can't outrun it. So at this time, we're going to take a 10-minute break. So we'll just be back here at 11 o'clock. And John is going to teach on tabulated data. Got about 2 minutes, John. All I see is your presentation slides, so you're still successful.
Great. I kind of went into panic mode there for a second. I was doing everything. I was going over the slides in Teams, and I was like, I did a little test run early this morning in Teams, and I'm like, oh no, it's in Zoom. So I kind of jumped on. I was like, well, let's figure this out. So I appreciate the help on it.
Yeah, it's a great looking slide too.
Yeah, thank you. Yeah, I kind of wanted to, I changed up the background pictures a little bit in each slide just to kind of relate to what we're talking about in each of them. So
Yeah, you got it. And I can't see when our students get back in the classroom. All I see is you. So
yeah,
just,
they just hopped in. So
okay.
We're here.
So whenever
going on,
you're
guys?
ready, you can take it away, John.
Sure. Thank you, Jason. Good morning. I'm John Schultz. As you can see, I'm the new regional safety supervisor for our West operations, which includes Illinois, Indiana, and Minnesota. Jason's given me the opportunity to speak with you guys on all the speed shoring and how to do it correctly, but most importantly, how to do it safely. If you guys have any questions during this training, please let me know. Don't be afraid to ask, okay? And let's get into this. Tabulated data. Every excavation that requires speed shoring must have this tabulated data on site, and you must understand what the document means, but more importantly, how to use the speed shoring system safely. The document must be kept in your truck at all times on every excavation. We're looking into, I know Jason and I were talking about this earlier with somebody else in the week, last week about getting it digitized and putting it into ServiceTitan in some way. So for the time being, though, we're going to keep the hard copies in the trucks with us at all times. So let's go to, if you guys want to open your tabulated data, and let's go to page 2 so you guys can follow along. So it says a trained, competent person shall supervise all excavation operations, ensure that all personnel are working in safe conditions, and have thorough knowledge of this tabulated data. The competent person shall have the authority to stop work when it is unsafe for workers to enter an excavation. As an excavation team member, I want to say you also have stop work authority. You can stop work on any excavation if you find something unsafe. If you do find a situation unsafe, make sure everyone is cleared from harm. Call myself at 330-815-3778 or Jason at 330-488-4141. Alexa, stop timer. Sorry about that. We are both happy to help work through the challenge so that work can begin again. We will reach out to your operations manager. We'll all work together to ensure the excavation is safe for you to continue. Our job, Jason and I's job, are to ensure your guys' safety at all costs. It's important to know that the tabulated data is not intended to be used as a job-specific safety plan. It is to be used by you, the competent person. It is designed to supplement your training, your knowledge of the job conditions and soil types you may come across. All installation and removal of shoring and shielding shall be from above ground only. Never remove the speed shoring and the fin board from inside the trench, always from above ground. The competent person has sole responsibility for job site safety and the proper selection and installation and removal of the shoring or shielding equipment. Speed Shore's tabulated data on page 3 complies with OSHA standards as stated in CFR 29, Part 1926, Subpart P, excavations. We're going to go over to tables VS1, VS2, and VS3. This is found on page 6. of your tabulated data. It's important to understand under the scope what they're talking about when it comes to soil types and how it relates to the speed shoring. So let's go to page 6 and review that data. So tables VS1, VS2, and VS3, you'll see that there. It provides data for the maximum capabilities of our speed shoring in terms of vertical and horizontal spacing requirements for all 3 types of soil. Something to remember, we will come in contact with type A and type B soils, but in our enterprise, we classify all soil types as type C. So the reason being is because all type C soil has been previously disturbed, and typically we're going in to repair a sewer line or water line that has already been installed, which means the ground has been previously disturbed. No matter how old the line is we are working on, it will still be classified as type C soil. Another reason we classify all soils as type C is because it offers the highest level of safety in terms of shoring requirements. So we will focus solely on this table VS3, type C soil. Looking at the table, we can see 3 different excavation depths: 0 to 10 feet, 0 to 20 feet, 0 to 25 feet. Important to know, we do not do excavations 20 feet or deeper. In fact, if you're going to be doing an excavation at 13 feet or more, please call Jason or myself so we can help you and your field supervisor walk through the protective safety plan to make sure we have figured everything out to keep you guys safe. The average depth, though, typically for our enterprise is 8 feet. So most often we'll be using the first section of 0 to 10 feet, sometimes 0 to 20. So looking at the table, we can see that for an 8-foot excavation right here, so it's 0 to 10, we're right in that 8-foot area. Our maximum horizontal spacing for our speed shoring cannot be greater than 6 feet apart. Vertically, our spacing cannot be greater than 4 foot. I want to note that any excavation at 6 feet or more requires 2 speed struts. Jason mentioned this earlier in the first module. It's very important to know any excavation at 6 feet or more requires 2 speed struts. It's also important to understand the width of the excavation. We use 2-inch diameter cylinders only for our speed shoring equipment. In this table, we can see we can use it from 0 to 8 foot, 8 to 12 feet, and 12 to 15 feet. We dig trenches. It's important to also understand that an excavation is no longer a trench when it gets to be 15 foot wide at the bottom. It becomes an excavation again. Trenches are deeper than they are wide. I'll say it again, trenches are deeper than they are wide. So at 15 foot wide, it is no longer a trench and it goes back to being an excavation. An excavation is any time we remove earth to create a hole. Table VS3 is your point of reference for almost all of your excavations. The integrity, let me move this a little bit out of the way here. There you go. The integrity of the speed shoring equipment is strong enough to handle all of the depths listed in VS3 table. So 0 to 10, 0 to 20, 0 to 25 foot. Remember, the 20 to 25 foot depth is deeper than we go, but the information provides you with the knowledge to know that the equipment you're using is rated safely for the depth of excavation we intended to use it for. So let's go ahead and go to page 8 of 8. The example on page 8 of 8 in your tabulated data showing you examples of typical installations. So we're looking at figure 1. You can see they're using speed struts here, and they're also combining it with the fin board, 4x8 fin board right here. There's 2 of them. In figure 2, it shows a setup without the sheeting. In our enterprise, we will only use the setup in figure 1 with fin form boards in combination with our speed struts. The reasoning behind this is that it provides the highest level of protection for the workers required to be in the trench. We are all aware that the soil types that we come across will be either A, B, or C, but we will always classify the soil on our job sites as type C, and therefore we will always use speed struts in combination with the fin-form boards. All right. Let's go back to page 3 in your tabulated data. Going back to page 3, we're going to look at section 3 on soil classifications. It's important for you guys to read through all 8 pages of this data on your own and thoroughly understand what is presented to you. If you ever have any questions, please reach out to Jason or myself. You can call or email either of us with any questions or concerns you ever have. So soil classifications, if you ever taken a trenching class or OSHA 3015, you will have had the opportunity to better understand the different soil types. So the competent person in 3.3, it must monitor the excavation for signs of deterioration of the soil as indicated by, but not limited to, freely seeping water or flowing soil entering the excavation around or below the sheeting. The competent person must be able to monitor the entire trench for signs of deterioration. This is important to understand because if we can see a fissure form on the walls and know that the possibility is there for a collapse, we have the ability to mitigate it in order to keep everyone safe on the job site. You as a competent person must be aware of the signs of deterioration at your dig site. Now let's turn to page 4. We'll look at that. So on page 4, look down to section 5, basis and limitations of the data. In section 5.1.3, we see a section for plywood. We must understand that we cannot go to Lowe's or Home Depot to buy our plywood. This is not the kind of plywood we use for sheeting in our trenches. The type of sheeting we use is 3/4 inch thin form board. It has a bending strength of 3,600 PSI. I'll say it again, it has a bending strength of 3,600 PSI. It's important to know not only because it's a test question, but that it is much stronger than the plywood we get from the big box stores. We will never use regular plywood as sheeting for any of our excavations. And I'll say that louder for the people in the back. We will never use regular plywood as sheeting for any of our excavations. You guys understand that? Good. The only reason we would ever use regular plywood is to cover an excavation if we are going to leave it overnight for protection. We only use fin form boards for our sheeting inside the trench. Okay, so in section 5.2, we're going to look at that. The fin form board must extend past the top of the excavation 18 inches. It cannot be placed more than 2 foot out of the trench from the bottom. We can then maximize the amount of use from the fin form board, but we cannot pull more than 2 foot off the bottom of the trench. We can do this only if we don't have water in the trench or if there is water undermining your excavation. In section 5.6, if in excavation 6 feet deep or less, 1 hydraulic cylinder is required in each vertical plane. So you only have to use one cylinder 6 feet deep or less. The cylinder shall be no more than 4 foot above the bottom of the excavation and no more than 2 feet below the top of the excavation. In excavations 6 feet to 10 feet deep, there shall be a minimum of 2 hydraulic cylinders in each vertical plane. The horizontal base spacing shall be shown in the tables VS3. All right. Any questions on that, guys? Good. Let's turn to page 5 and look down at section 5.15. Again, I want to stress the importance of taking some time today to carefully read through the entire document. It's super important your understanding of this document is going to help you and your crew be more knowledgeable and safer while on the job site. So in section 5.15, it states, water flowing into an excavation from either above or below ground will cause a decrease in the stability of the soil. We can work in the rain, but we can't work in a rainstorm. We can have a little water coming into the trench, but we have to mitigate it. Remember, 2 inches or more water in your trench is considered a drowning hazard. We can create dams, trenches, or use trash pumps to remove the water away from the trench. Let's go on to page 7 of 8. On page 7 of 8, you're going to see 4 separate stamps from 4 different licensed engineers. These certify that this speed shoring is appropriate to use for us. We want to be sure we are inspecting the speed struts, though, for damage before we ever use them. On every site, every excavation, inspect them. The certification only ensures that they are in compliance with the parameters of table VS 1, 2, and 3, but it does not guarantee they're in proper working order because the equipment could have been damaged or abused on another excavation. Therefore, it's extremely important that you inspect your speed struts before each use. Never put your safety in someone else's hands. Always inspect your tools and your materials before the job starts. Okay? So on page 7, there's also notes to the tables of VS1, 2, and 3. Remember that 2-inch diameter, so we use 2-inch diameter cylinders. They have a structural steel oversleeve of 3.5 inches. The bottom of the sheeting shall extend 2 feet off the bottom of the excavation. There's an indication of any possible loss of soil from behind or below the support system. Sheeting must extend to the bottom of the excavation. So that means if you're starting to see sloughing or fissures happen, we need to move that sheeting back down to the bottom of the excavation. We only use 4-foot wide sheeting, 4x8 sheeting, fin form board. Anything over that's going to be extremely heavy, and no, I wouldn't want to lift that stuff around and try to position it into those trenches. So 4x8 is all we use in the fin form boards. Horizontal, when the horizontal 4-foot horizontal spacing is exceeded, the open spaces between the sheeting must be monitored as well for sloughing and raveling of the excavation face. So you start seeing dirt drop into there or from behind the boards. Yeah, it's time to reassess the situation. The bottom hydraulic cylinder shall be a maximum of 4 feet above the above the bottom of the excavation. So remember that the bottom hydraulic cylinder shall be a maximum of 4 feet above the bottom of the excavation. With that being said, I appreciate you guys sitting through this. I kind of went through it a little fast. I know Jason's like, oh. But if you guys ever have questions or concerns, please take your phones out now, scan each of these QR codes, and it will save them to your phones. If you open your camera app, you can take a picture of this, tap on the link, and it will save this to your contacts. Jason Myers QR code's above, mine is below. Thank you for listening, and Jason, thank you for having me do this. We'll get more practice in as we go along. Thank you, sir.
Sounds good. All right, so we ended this section 1 with the fatality here.
Costs as high as they are right now.
Oops, you don't want that one. Let's see here.
I have a cheese steak. Seems like a minute ago.
Sorry about the commercial.
Family business. He then asked more.
Yeah, both of those men had absolutely nothing to say as they walked in today. Dennis Botticello, the owner of Botticello Incorporated, and his employee, Glenn Locke. They've both been charged with first-degree manslaughter connected to the death of their construction worker, Dennis Slater. These arrests coming today, but this incident dating back to July of last year. What's your message? Are you remorseful at all? 67-year-old Dennis Botticello walked in the front door of the Vernon Police Department. You didn't use the trench box. And snuck out through the back door after he and 65-year-old Glenn Locke posted bond.
It wasn't just an accident. This could have been prevented.
The pair is charged with first-degree manslaughter in the death of 56-year-old Dennis Slater, killed when the sides of a dirt trench collapsed on him at Laurel Woods Farms, and it wasn't the first time.
The trench did fall in a couple times before that.
A warrant shows Slater's text conversation with a friend asking how his day was. Not good, responded Slater. In a trench by myself today. Trench collapsed twice. And when questioned by police why proper safety measures weren't used, Locke responded, I guess we played the odds.
Unfortunately, the odds were not in Mr. Slater's favor that day.
The trench was about 120 feet long, 8 feet wide, and 8 feet deep. According to the federal investigators from OSHA, there were no indications that the sides of the trench had been sloped, benched, or any other trench safety measures had been instituted. That includes what is typically called a trench box, a metal insert meant to reinforce the dirt sides and keep it from collapsing.
This hole was nearly, quite long, and they failed to have any trench boxes. They were very careless in their actions, and somebody died as a result of this.
And the rest, of course, come after a lengthy investigation involving local, state, and federal officials, including OSHA. Both Botticello and Locke will be in court on Monday before a judge, with, of course, the main difference between murder and manslaughter being intent. We're live here in Vernon. Matt Karen, Fox 61, Connecticut's news station.
So I wanted to show that slide because there are people out there who are so negligent that they're willing to put other people's lives at risk. And that is not something that we do here at the Suppleway family of businesses. We have progressive discipline that we follow down the line all the way to termination, unfortunately, here, because people have made mistakes. And we are dramatically minimizing those in the last couple of years. So if you ever have a question about the safety of an excavation, you can call me. I can get involved in excavations without everybody knowing who called me because of the technology that we have. It is important that we are utilizing the training that we're doing, and that if there's a deviation in our safety policy, that I know about it so that we can fix it, because everybody is important and everybody needs to go home in the same way that they came to work. So soil distress is caused by a variety of different things. One of them is vibrating equipment nearby. Our caterpillars are really smooth. A couple of our branches have bobcats, and they're pretty smooth also. But anytime somebody's in an excavation, I would like the equipment turned off. And roadways, is the closer we get into the roadway, or the road rather, we may want to ramp up some extra protections, and those look like getting a roadblock, blocking off the whole section of road. It just depends on where we're at, because we don't want a full semi of stone driving by an excavation where our team members are in there with shoring. Even being in there, it still adds significant risk. So does water. I'm in the Allentown branch today, and a few months ago, I was back out here and we had an excavation in the street. It was a light rain, but because of where we were digging, all of that light rain accumulating in the road, running towards our trench, it created a significant safety hazard that we had to address. So keep in mind that even light rain, depending on where you're at, it poses a risk that we have to mitigate. Even hot, dry weather without the moisture, it can crumble a little bit. So we just want you to understand that the competent person is going to look for trenching hazards. You're going to look for signs of a possible cave-in. Even when we have the shoring in place, or the shielding, the speed shoring or a trench box, it's still important to be able to identify what's going on with the walls behind that. Sometimes, depending if it's a trench box, you're able to see back there, because even in a trench box, if you have 6 inches or so of a gap between the trench wall and the trench box, it's still enough to move that trench box, even when they're all locked together. And we want to be aware of what's going on, specifically for the underground specialist who's in that trench box. We want to put a plan together. Hey, I'm noticing that there's a crack here on this one wall. If I notice it getting bigger, I'd like you to go to the north part of the trench box. That'll give you a little bit of cushion. So just listen for my words if we get to that point. That's part of the plan. Understanding the hazards relating to the soil type, more risk, more danger as it is involved with type C soils. Definitely more dangerous than A soil, but we're classifying everything as C. We're treating it all like C. Here, we'll do this video next.
Like it. Thank you very much.
There are rules that must be taken into account before work on an excavation begins. All excavation work must be carried out in accordance with the industrial health and safety regulations, or with the specifications and requirements of a registered professional engineer. Utility services in the area, such as electrical, gas, steam, water, and sewer, must be located and assessed for hazard potential. Pointed tools must not be used for probing to locate underground gas lines or electrical facilities. Trees, utility poles, rocks, or similar objects in the vicinity must be secured or removed, and a clean, level area extending 2 feet back from the edge of an excavation must be maintained. The side of the excavation must be trimmed or scaled to remove any loose material or rocks. Safe access must be provided in the immediate area where workers are employed in trenches over 4 feet deep. Ladders must extend from the bottom of the excavation to at least 3 feet above ground. Another consideration when excavation work is being done on a traveled roadway is the need for traffic control and high visibility clothing. Any engineered excavation support system must have certified design documentation available on site.
That means basically if we're running a trench box, the trench box needs to come to us with the tabulated data also, because it has specific requirements. Sorry about that. We want to make sure that we're following that too. I do have some of those tabulated data that I can email you if they forget, to try to save some time. So that's why it's important just to keep my phone number on file, or John's as well. Protective systems that are available are sloping and benching. Because we classify the soils as C, we can't bench according to regulatory standards. We can slope, but it goes basically against our business model in the sense that we're in neighborhoods, we're in the tree lawn, we're in the front yard, and we don't have all of the spacing that's required to slope. That's why our best options are speed shoring or trench boxes. When we rent a trench box, it adds additional costs that the customer needs to be aware of, the field supervisor needs to be aware of. So it just takes a little bit of extra time and more communication to make it safe for you. You might get into a trench box situation that could have been taken care of with speed shoring, but the locate was wrong. And so your excavation is 4 feet wide. You need to move it over so it's 6 feet wide. You might want to talk about a trench box at that time. So that's a couple of situations that we can get into. We're going to skip this. We've already covered some of this here. This timber shoring, typically Chicago uses it. You're still allowed to. We don't use it in the business. Here is how to install the speed struts for speed shore. This is the Ohio Fire Academy teaching firefighters how to deploy speed shoring for rescue purposes. So this is a part of their training.
Strut itself. We want to install our hydraulic hose to the strut, pull the collar back, put it on the fitting, make sure it's securely fastened. Our strut has been pre-sized to the trench we're going to be working in. We check our operating range, 36 to 47 inches. We're roughly working with a 42-inch opening, so this falls well within the range. Before we install the strut, we want to make sure we have everything set up and ready to go. Make sure our pins are properly in the top of the strut, not in the bottom. We put our installation ropes on each end. Make sure all our pins are through and the bearings are out each hole. And just make sure that we inspect the strut to make sure it's ready to go in the trench. All right, we're now ready to install our first strut system. As you can see, there is a trench boss or a rescue supervisor at the end of the trench. What his job is going to be is to establish the placement of these struts. The two rescuers on the end, their job is to establish that it is square in between the fin form panels. All right, the commands we're going to use on these is going to be lower ram and lower base. All right, so the rescuer at the end of the trench will instruct the gentleman on the ropes to lower the strut. Once it is in place, he is going to assure that it is square in the trench, and then we're going to call for our command to feather. All right, now in the trench, now we're going to discuss how we install this first strut. As you can see, it is square, and it is square with the panels, and it is level with our trench floor. This is imperative. Like I said, you go back to that double funnel effect.
I want to interrupt him for a second. The best way to install this, all of this has to be deployed or installed in the trench from above. So if you have one hand pump, you're going to connect the hand pump to the speed strut. Your best option is to install the top speed strut first, because you can still reach into that excavation and disconnect the hose, reconnect it to your second strut, and set that all the way at the bottom, 4 feet away at the most from the top speed strut, and leave it connected. That way, when you're taking it apart, you can change the valve on the hand pump, allow that hydraulic fluid to go back into the hand pump and pull it back out, and then hand disconnect that hose and reconnect it with your hand by just reaching down into the excavation. I don't think they cover that here, but in real life, set the top one, then the bottom one.
It's got to be level. It's got to be square. Also, if you notice, there is no actual mechanical capture of the trench panels to the hydraulic shores. These ropes will stay on this shore at all times. If this shore were to depressurize, these ropes are what's going to keep it from falling to the trench floor. What they're going to do now is lower the second strut into the hole using our operating rods or our lowering rods. These can be used in conjunction with the ropes. Gives you a little bit more control, a little bit easier to place. Our trench boss is still going to call the commands from the end of the trench. He's going to line the strut up. Now he has a nice reference point.
There's no expectation to use their commands, the feathering, all that kind of stuff. It just needs to be level and square.
This first strut. That's why it's imperative that first strut gets set level and gets set square.
Lower base, lower. Stop. Feather. Stop. Lower base. Stop. Yeah, square. Good. Pressurize.
All right, our second strut is now in place. Once again, you can see our spacing here, well within the 4-foot parameters. We take our ropes, tie them off to the top of the strong back. Like I said before, there is no potential capture of these struts. All right, on the hydraulic shores themselves, if you have the ample equipment, these hoses can stay attached throughout the entire operation. If you do not have ample equipment, you need to use these hoses. These hoses will be removed from these struts with our large tool, hose tools that we have up top side. And they'll demonstrate that here in a minute. How we remove all these fittings from top side. You never have to have anybody down in the hole to do that process. You can see he's taking the tool, he's hooking it in behind the handle. The flange here fits inside the fitting, and all he has to do is one quick motion back, and that hose will pop off. The strut is now self-contained with the pressure inside of our one-way valve here. One note of caution to remember about your hydraulic struts. There is, like I said, no mechanical capture of this strut at all. What is holding all this earth back is the hydraulic pressure inside the strut itself. If this valve were to become struck with an object, with a tool, etc., it will release pressure. So always be careful to operate very gingerly around these hydraulic valves, because if this gets depressed and that pressure is released, the strut will collapse.
You guys have any questions about that? There's a couple other examples of how to install it. Because it's Class C, we're always going to use the fin form boards. Provides the highest level of protection. You don't always have to disconnect it. You can leave it connected. The double strut application. You can use that if it's A or B elsewhere, but not here. Here's a quick video on FinForm board.
Hey, Chris Allen here for Allen Trench Safety. Today we're bringing you FinBoard. In our previous video about hydraulic vertical shorts, I said you may or may not need FinBoard. Today we're going to find out why. Here's your tab data. Now tab data is basically the owner's manual for your shoring equipment. It'll tell you how to use your hydraulic vertical shores and the spacing required for the type of soil and the depth of your trench, both horizontally and vertically. Remember, every job site should have a designated competent person that can determine soil types. In the tab data for hydraulic vertical shores, FinBoard is required if there is unraveling of the soil and possible undermining of the cylinder. FinBoard is a pressure-treated plywood that has an allowable bending strength of 3,600 psi. There are some alternatives listed in the tab data, like steel plate and sheet piles, as long as they have the equivalent strength equal to FinBoard. Now here's a trick in the field to help your guys. If your soil type calls for FinBoard, put ropes both on the sides and on the ends. This will allow the person in the field to utilize it in both the vertical and the horizontal position. That's all for today. Stay tuned for more at Allen Trench Safety.
It makes it nice when you have those the ropes, because I teach the guys to put the spud bar through both of them. You stand both up, run the spud bar through it, and then the excavator, the bucket, and the tooth, the claw, will grasp the spud bar and set it in there. Set it, place it, and remove it. That'll make a big difference. So do you guys have ropes? Muncie? Yes. Okay. So the shielding side of trench boxes, we typically get these from United Rentals. There is another place we can get it from at different branches, but I think you guys are United Rentals where you're at. They can be permanent, they can be portable, they can be buildable. This is an example of a trench box, a 4-wall trench box you might need if you're digging in sand. I like the buildable kind because I like to remove the bottom panels on the long side to allow the underground specialist to be able to connect to the main line, the sewer, that type of thing, a lot easier than if the wall went all the way down to the bottom. Trench boxes are designed to stack. If you're stacking a trench box on top of each other, they need to interlock, and then there's different pins that need to be set to make sure that they do lock together. You can use trench boxing in combination of sloping and benching, that type of thing. Again, we don't bench here, and we typically don't have the space for sloping either. Skip these trench box installation. All right, so if you can unmute your computer here. So far, what you've learned, what's wrong with this picture?
Should do fin boards.
Yeah.
That and the ladder is sitting right on top of the jack.
Okay.
Should have 2 strips.
So you remember the ladder requirement needs to be 3 feet high. We make a mistake by assuming 3 feet equals 3. I'm sorry, yeah, 3 feet equals 3 rungs. And it actually isn't, because the last section of every ladder is 8 to 10 inches. It's never a full foot. So it actually works better ergonomically if you raise it so that there are 4 rungs out of that trench. It is a whole lot easier getting into the trench with 4 rungs than 3, and it has to be 3 feet. That is a test question. So we did that. So what is some challenges with this excavation, Logan?
It's a lot of. They look like they're just off-centered a lot. They're
Okay.
not vertically, they're just kind of thrown all over the place. A lot of water in the trench. Looks like the soil's starting to kind of, there's just a lot of gaps that can still leak through.
Yeah,
The
it's a hot
foundation of
mess.
the house is exposed.
It sure is. There is, if I assume that those fin form boards are 8 feet long, they have to have at least 2 struts, 2 vertical struts on them. So a top one and a bottom one. So that's definitely there. I like that you notice the water that has to be mitigated. What's wrong with this application of our protective system?
Well, it's not really holding anything. There's no dirt behind the wall.
Yeah, it makes for an interesting picture, and that's about it, right?
Yeah.
There is a test question that basically deals with this photo here and the opportunity for the speed strut to kick back, to kick out, because the walls are not straight up and down. Most of our excavations aren't perfect, but they should never be like this. In this particular situation, you have a couple of options. You can use a trench box, you can backfill and redig, which is a lot of extra time. On your shoring, you want to make sure that you're inspecting that every day. If the fin form boards are broke, cracked down the middle, vertically or horizontally, there's no structural integrity there. We can use it for different applications, but we can't use it for inside of the trench. It needs to be in good working order. We'll talk about this here in a little bit. Water accumulation, we talked about that already, 2 inches or more. There's a photo coming up here soon that has a trash pump, but the exhaust is facing towards the trench. All of that byproduct of burning fuel is heavier than air, and it's going to affect the water, or I'm sorry, the air that you breathe, easy for me to say, at the bottom of the trench. And that is something that the competent person needs to be aware of, that the exhaust for all gas powered equipment needs to be away from the trench so it doesn't make the air toxic. It doesn't deplete it of oxygen. Trenches that are 4 feet deep or more must have entry and exit within 25 feet of the worker. So if your trench is 50 feet long, you can have one ladder in the middle, or you can just keep moving it a little bit closer to wherever the person is working. Just because the regulations say that it's 25 feet doesn't mean that it's not going to be better if that ladder is 10 feet away from the person versus 25, just because we want to get them out. We can make a part of the trench where it's a sloped ramp to get in there. Again, we don't typically have that kind of space. Typically, ladders is the way to go. Fiberglass ladders. Let's see here. A lot of this between John and I, we've already covered. Trench inspections. When I started here, they were paper reports that had to get scanned in and all that kind of stuff. So now these inspection reports are in ServiceTitan. They use conditional logic. So if the answer is no, it typically, the rest of the questions that are pertinent to that one go away. If it's yes, it may ask for more detail, but it's something that you don't have to memorize. You just answer the questions until you get to the end and upload the photos on your tablet if you're the competent person. It makes it really smooth. This is what one of them looks like if you print it out or if you're looking at it in ServiceTitan. In your trench inspections under pre-dig, we want you to take pictures of all the utilities. Taking pictures is one thing, but actually recognizing, hey, I don't see any electric flags here. Where's the electric? Is that on the opposite side of the house? Recently, we had an excavation where 811 marked the house across the street, and our foreman didn't even recognize it and started digging until one of the underground specialists said, hey, we can't dig. None of this is marked. They marked the wrong side of the street. So just thinking through all of this, what is missing? And you're able to work through all of that here. I'm going to show this video and then we'll wrap it up for our next break.
Utilities are as important as they are potentially dangerous.
Public safety and interruption of services is the key and primary concern.
We want to keep the employees and the citizens safe. We want the job to be done in a safe manner without damage to utilities underground.
We have a shared responsibility to know what's below when we start a project. And we want to make sure that that project's safe for everybody.
We all know that digging safely around our underground infrastructure is a shared responsibility. Facility operators, locators, and excavators are all in this together and have a role to play in the prevention of damage or a serious accident. If any of these stakeholders fail to meet these responsibilities, the damage prevention process will be compromised. Damaging a buried utility can impact important services, as well as public safety and the safety of your crew. So even if you've excavated on a site previously, never make the mistake of thinking that you remember where the lines are buried. Old marks from a previous job and photographs of the location when it was last marked don't cut it. Pre-mark your intended dig site in white. Usually flags or water-soluble spray paint is best. The solution is simple. Depending on your state law, Make a free call to 811 at least 2 to 3 days before you plan to dig to ensure that facility operators accurately locate and mark their facilities. That's the first step to safer digging. Always call 811. Here's how it works. 811 is our national one-call number, connecting you with your local one-call center, no matter where you're located in the country. The One Call Center is your conduit to communication with all registered facility operators in the area. In some complex digging situations, a call center can even arrange an in-person meeting between the excavator and the facility operator to discuss the underground infrastructure. At the call center, helpful operators will ask you for relevant information about your digging project.
Thank you for calling 811. This call is being recorded. My name is Mary. How may I help you?
At a minimum, be prepared with the following information: the exact location of your dig site, the type of work you'll be doing, and your start date.
Address or street you are working on.
Main Street between First and Third, we're on the north side of the property, and I will pre-mark in white where I'm gonna be digging.
Be as clear and exact as possible in your answers, and always confirm the information.
And when are you planning on starting the work there?
We're digging next Thursday.
Okay, so the area should be marked by Tuesday. Let me verify your information and then please be ready to take down your ticket number.
The call center will issue a dig ticket, detailing which companies will be notified to mark the approximate location of their facilities.
That is correct. All right. I've already listed the facility operators that will be notified. Now, do you have any questions?
Nope, I'm set.
It is extremely important that excavators review the information associated with their locate request to make sure it is submitted correctly to the facility operators. Inaccurate information could cause delays, failed responses, or even potential damages. Some one-call centers even accept latitude, longitude, or GPS coordinates. The more precise your information, the better. Many one-call centers also offer online dig requests. These electronic or e-tickets allow excavators to submit their information at their convenience. Always be sure to maintain your request ticket number. The dig ticket, whether generated online or by your call to 811, is soon transmitted to facility operators, who will send out locators to mark the underground lines of your dig site.
Steve, our locator for that area, call and have him come out and verify that.
Depending on state law, this process takes between 2 and 3 business days. This is the second step to safer digging. Always wait the required amount of time. Though the laws vary by state, you typically need to call 811 at least 2 to 3 business days before any digging project in order to give each facility operator the time to respond and mark their lines. It is the facility operator and locator's responsibility to respond to locate requests as prescribed by law and in a timely manner. This is the foundation for step number 3 of safer digging: locate accurately. Facility operators should keep accurate records of underground facility locations, be members of their local one-call center for efficient communication and response, and accurately locate and mark underground facilities at excavation sites. When a locator responds to your job site, they'll be looking for your proposed excavation site, which should be marked in white, as well as being detailed in your dig ticket description. Locators use a variety of markings to communicate what is buried underground at your dig site using the following color code. Red marks your electric power lines and lighting cables and conduits. Orange marks your communication, cable TV, alarm or signal cables. Yellow marks your gas, oil, steam, and petroleum. Purple marks your reclaimed water, irrigation, and slurry lines. Blue is your potable water. Green marks sewer and drain lines. And pink is a color used for temporary survey markings. White is always the color used by the excavator to designate the proposed excavation site. If the dig area is free of buried lines, the locator will mark the site with an OK or No along with the company name, either with a flag or painted on the ground near your dig site. Once the required waiting time has lapsed, check all of the marks. And if it appears that a utility has not been marked and you've not been otherwise notified, call 811 again, who help expedite a response and to record the discrepancy. This brings us to steps number 4 and 5. Respect the marks and dig carefully. When carefully planning your dig, be mindful of the marks and required tolerance zones. The tolerance zone is the width of an underground utility, plus a specified tolerance distance on both sides of that utility. generally between 18 and 24 inches, depending on state law. Never use mechanized equipment within the tolerance zone, but rather utilize hand or vacuum digging or other non-invasive equipment to determine the exact location of the utilities within the area, and take extra care to avoid damage and personal injury. With today's modern mechanized equipment, care and calculations are more important than ever. Backhoe excavations specifically are known to cause over 1 in 4 utility damages. Trenchless technology like underground boring or horizontal directional drilling has become a popular approach with its minimal surface disruption. But extra care should be taken to monitor and expose nearby utilities, and always include back ream radius in your safe distance calculations. Potholing is an important method for identifying the horizontal and vertical location of buried facilities, and should be utilized when open cut excavation is taking place within the tolerance zone, or at intervals along the boring route for trenchless operations. In congested areas where several utilities are crisscrossing or in close proximity to each other, locating accurately becomes more difficult, and potholing is highly advised. No matter what equipment or expertise is being employed on a dig job, always remember step 5, dig carefully. Different digging environments present their own challenges, and all stakeholders in the damage prevention process have to be highly adaptive and extra careful. From rural and agriculture projects to high-density urban work, underground utilities need to be marked and protected. But even when observing the 5 steps to safer digging, minor damage can occur. A slight nick with a shovel, a little cut when hand trenching, or maybe your excavation might expose an existing problem. Either way, report any damage immediately by calling 811 or the facility operator directly. Even a small nick without signs of leakage now can become a serious problem with time, corrosion, or if underground root systems change. Report it now. If the damage causes an emergency, immediately call 911. Take reasonable steps to ensure public safety and notify the facility operator. Calling 811 before you dig is an essential first step to safer digging. So plan ahead. Make it a standard part of your process. By waiting the required amount of time and having your dig site marked accurately for all underground utilities, respecting those marks and digging safely, you'll be doing your part to avoid interruptions to important services, being held responsible for costly repairs, as well as preventing potential injuries or deaths. When we all commit to these essential 5 steps to safer digging and maintaining a high standard for damage prevention, we can go to work knowing we are keeping our crews and the public safe. For more information on safe digging, visit call811.com.
All right, guys, at this time, we'll take a break. Are you guys going to try to eat some food real quick? No?
Why not?
Okay. So then let's say 12:06. We'll be back at it here.
Thanks.